Hello everyone. So for this next video, we're going to go ahead and talk about the next type of transformation, which is a reflection. And this is kind of a good visual representation of what you're seeing. If you have some kind of figure, in this case triangle ABC, what you're essentially going to do is you're going to reflect it over some type of line that we're going to call the line of action. Or line of reflection, I'm sorry. And so yeah, that's the best way that you can kind of think of it. This is essentially flipping over that line. So there are different types of lines of reflections that we're going to see in this section. The first one being the x-axis, right, which you can kind of see in this first example. They're going to ask you to get this figure and flip it over this x-axis down here. And then the other one you'll see a lot of is you'll see them ask you to flip something or reflect something over the y-axis, and that being that vertical axis there. Sometimes they'll ask you to flip it over vertical or horizontal lines. So you just have to remember that vertical lines are in the form x equals some kind of number, and horizontal lines are in the form y equals some kind of number. I like to think of it as if it's an x equals a number, it's going to cross the x-axis at that number. Or if it's y equals a number, it's going to cross the y-axis at that number. So this will, inherently be a horizontal line, and this will obviously be a vertical line. Sometimes they're going to ask you to reflect something over a diagonal line. There are all obviously different types of diagonal lines, but the two that we're mostly going to focus on is y equals x or y equals negative x. All right. So as far as doing the problems themselves, I tell my students all the time, look, if you know how to count, you'll know how to reflect figures over lines. So let's just kind of look at this one, for example. If I have triangle ABC, and they're saying reflect this triangle over the x-axis, well, this right here is the x-axis, right? I like to teach my kids to just do a counting technique. So you essentially just have to remember that every point, all right, they're going to be the same distance as from the x-axis, once you see the original and the reflection. So, for example, you can kind of see it over here. Notice how from point B to the line of reflection, this is the same distance as this distance from the line of reflection to point B, right? Same thing over here. C, notice how this is the same distance, and A, with the new A, is also the same distance away from the line of reflection. All right. So we're essentially just going to kind of do that here. So I'm going to look at point C. I'm going to say, okay, well, point C is 1 point away from the line of reflection. So my new C is also going to be 1 point away from the line of reflection, but on the other side, right? So this is my new point C. B, well, let's see. Let me count. 1, 2, 3, 4, 5, 6, 7. Point B is 7 points away from my line of reflection. So my new B, right, which we usually say with a tick mark, my new B is also going to be 7 points away, but in the other direction. 1, 2, 3, 4, 5, 6, 7. There's my new B. And then A, 1, 2, 1, 2. There's my new A, right? So if I went ahead and just kind of connected my dots, I'll try my best to make this look somewhat good, right? You'll see that my new figure is reflected across the x-axis. Now, a lot of times they'll ask you, well, what are the coordinates of your new points? Well, let's see. My new A, if I start from my origin, is 1, 2, 3, 4. 4 to the left, down 2, so -4, -2. My point C is 1, 2, 3, 4, 5. 5 to the right, down 1, so +5, down 1. And then my B is 1, 2, 3, 4. So +4. 1, 2, 3, 4, 5, 6, 7. -7. Right? Now, I'm going to go ahead and also teach you guys the rules as well. Like if I look at my original figure, my original A, right? A without the tick mark is 1, 2, 3, 4. So left 4, up 2, so -4, 2. My original point B is over 1, 2, 3, 4, 1, so 4, 7. And my original C is 5, 1. Right? what you'll notice if you want to go ahead and compare, because I know some students are perfectly happy counting, some students just want the rule. You just have to remember that if you want to reflect something over the x-axis, right, the rule for that is that you're just going to go ahead and essentially change the sign of all of your y's. So you're going to keep your x values the same, but you're going to change the sign of all of your y values. All right. There is some value in using the rule. Sometimes you can do that a lot faster if you know what the rule is. I'm just a bigger fan of counting, the original coordinates and then recounting to get to the other coordinates. So let's go ahead and kind of do the same thing here. This one is saying reflect the rectangle PQRS over the y-axis. So here's the y-axis. And again, I'm just going to use my counting technique. So I'm going to look at P first. So P is 1 away from the y-axis. So it'll be 1 away on the other direction for my new P. Right? Q is 2 away. So I'm going to put 2 away here for my new Q. My original S is 1, 2, 3, 4, 5, 6, 7. So I'm going to count 7 the other direction. 1, 2, 3, 4, 5, 6, 7. And then my R is, let's see, well, it's probably 8, but so we'll say 8 this direction. 1, 2, 3, 4, 5, 6, 7, 8 in this direction. And there's my new R, right? So I'm going to go ahead and draw my figure. Poorly drawn, but you can still see it. You can still see that this is the reflection of that across the y-axis. So again, they're going to go ahead and ask me for the new coordinates. I'm going to go ahead and say, well, my new P is at -1, 2. My new Q is at -2, 1, 2, 3, 4, 5. So -2, +5. My new S is at -7. -7, 0. That's my R. Sorry about that. My new R is at -8, +3. And there you have it. Now let's go ahead and think about what the rule for the y-axis is going to be. So if I look at my original points, my original point was 2, 1. My original Q was 2, 5. My original R is 8, 3, and my original S was 7, 0, right? So if I wanted to come up with a rule for the y-axis, well, what essentially they're doing is they're getting the original coordinates of the x and y's, and what you'll notice is that, did I do something wrong here? Oh, I'm sorry. My P is 1, 2. Sorry, that was my mistake. 1, 2. There we go. So what you'll notice is that all of the y values stayed the same, but if I'm reflecting across the y-axis, they're changing the signs of all of my x values. So they're changing the signs of the x values, but they're keeping the y values the same. So there you have it. You have your rule if you're reflecting across the x-axis, and then here's the rule if you're reflecting across the y-axis. Now over here, this one is saying reflect triangle JKL over the line x equals 4. Well, x equals 4, where is that even located? So let's look at where 4 is on the x-axis. 1, 2, 3, 4. So that's x equals 4, and essentially x equals is a vertical line that crosses the x-axis at 4, right? Okay, so now they're not just asking to reflect it over the x-axis or y-axis. Now they want you to reflect it. I could probably use a different color for this, and you can't see it because of the pencil mark, but that's fine. All right, so you essentially want to reflect this over that line. So I'm just going to, instead of counting towards the y-axis or the x-axis, I'm just going to count towards this. All right, so my original K is here. It's 2 away, so my new K is also 2 away, but in the other direction. So there's my new K. My J is 3 away, so it's going to be 3 away in this direction. There's my new J. My L is only 1 away, so it'll be 1 away in the other direction. All right. So if I go ahead and look at my, if I see what my new coordinates are for K prime, it's going to be, well, sorry, let's look at J prime first. So J prime is at 1, 2, 3, 4, 5, 6, 7 to the right, down 1. So +7, -1. My new k is at 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 3 up, so 6, 3. My new L is at, let's see, 1, 2, 3, 4, 5, down 2, so positive 5 and negative 2. All right, so if they ever ask you to reflect the line over x equals something, I think it's just best to go ahead and just draw the line and then count away. All right, so let's kind of go on to the rest of these examples. This one says reflect the line over the line y equals negative 5. So if it's y equals negative 5, I'm just going to go ahead and draw negative 5 on my, so this is my y-axis. So negative 5 on the y-axis is 1, 2, 3, 4, 5. That's right here, right? And y equals is a horizontal line that crosses this axis at negative 5. So I'm going to draw nice and bold so that it's easy to see. And I'm just going to, again, just do my counting technique. So this n is one away this way too. P is 1, 2, 3 away, 1, 2, 3 here. There's my new P. M is 1, 2, 3, also 1, 2, 3. There's my new M. And then I just draw my new triangle. And then I'm going to go ahead and describe the coordinates for this one. So my new M is at 1, 2, 3, 4, 5, 6 to the left, so negative 6, and down 2, negative 2. My new N is at negative 1, 1, 2, 3, 4, so negative 1, down 4. And my new P is left 2, down 2, so left 2, down 2. All right. Now, when it comes to reflecting a figure over a specific line, especially y equals x, I personally think this one, instead of just counting, because this time, if you want to reflect over y equals x, well, that line is going to be something like this, right? Hopefully I don't screw this up, all right? But, and you don't have to do this every time, but this is what we're going to go ahead and we're going to get this figure and reflect it over this line right here. And I'll tell you right now, unless you're good at counting diagonally, I don't really think it's going to be easy to just go ahead and do that. What I personally would like to do is use the rule. So the rule for this is that you're going to get your original x and y's, and then your new x and y's is just going to be the flipped version of that. So it's going to be y, comma, x. All right, so this is one of those cases where I would actually go ahead and write what my original points are. So my original g is 2, negative 1. My original h is 7, negative 1. 7, negative 1. My original j is 2, 1, 2, 3, 4. 2, negative 4. That's my j. And I is at 7, 1, 2, 3, 4. 7, negative 4. All right, so now that I actually have my original points, it's easy to get to look at my rule. My rule is just telling me get your original x and y and switch them around. So my new g is going to be, well, the flipped version of that, negative 1, 2. My new h is going to be flip them around, negative 1, 7. My new j, flip them around, negative 4, 2. Flip these around, and you get negative 4, 7, right? And I'm just going to take it to the next step and go ahead and plot these points to see what so that you can kind of see what's going on here. My new g is at negative 1, comma 2. There's my new g. My new h is at negative 1, comma 7. So that's up here. There's my new h. My new I is at negative 4, 1, 2, 3, 4, up 2. There's my new I. And my new j is at negative 4, comma 7. So there's my new j. You'll see that that's my reflection. In fact, and you know, the way to think about the reflection is if I folded this over, right, over that line, this will land exactly where that is at right there. I hope that glare isn't bothering anyone, but you should be able to see what's going on. And we're pretty much going to do the same thing here. Now, for those of you who don't remember that y equals negative x, what that looks like in algebra, it's almost pretty much the same line, but in the other direction with a negative slope. So let me go ahead and draw that for you guys here. So it's with a negative slope right here. Let's see. Go ahead and draw it like this. And my pencil is running out of lead. Oh. All right, I guess it's time to use the pen. So, all right, I'm gonna go ahead and draw my diagonal. It's not perfect, but it's there. All right, so that diagonal is y equals x. So what I'm gonna do is I'm gonna go ahead and get this and flip it over in that direction. However, just like before, I would rather use the rule. So the rule, if I have an original x and y, the rule would be that they're gonna flip the x and the y, right? So it looks like that, but they're also going to change the sign of both of them. So flip them, change the sign for both. All right. So I'm going to go ahead and write my original points here on the side. I think that's just the easiest way. So my original s is at -1, 1, 2, 3, 4, 5, 6. So -1, -6. My original t is at 0, -3. My original u is at 1, 2, 3. No, wait. Is it? Yeah. 1, 2, 3, 1, 2, 3, 4. So my original u is at +3, -4. All right. So I'm just going to go ahead and use this rule. Flip the numbers. So 6 and 1. Change the sign. So if they're going to go from negative to positive. So that's already done. Flip the numbers. So 3, 0. Change the sign. So that is going to be positive. You can't really change the sign of 0. Flip the numbers. 4 and 3, and then now the 4 is going to stay positive, but the 3 is going to be changed to negative. All right, so that's what I'm going to go ahead and do. I'm going to go ahead and now I'm going to plot these points. So 6, 1, 1, 2, 3, 4, 5, 6, +1. There's my new s. All right, my new t is at 3, 0. There's my new t, and then my new u is at 4, -3. Right there. There's my new u. I probably should have wrote my t there, but that's fine. All right. And as you can see, there's the flipped version. All right. So as long as you can go ahead and use these rules, I think you'll be in good shape. You know, I personally, for some of these older problems, I think it's just much better to just use your counting techniques. But for the y equals, I just think it's just easier to remember the rules and plug and chug. All right. So hopefully that made sense to everybody. If you have any questions, of course, you're more than welcome to ask any of the geometry teachers. We all pretty much know what we're doing. So hope you enjoy the problem set or that it's easy enough, and take care.